Steam turbines. Objectives. In this session, we will view the history of steam turbines, study the classification of steam turbines, study the working principle of impulse and reaction turbine, specify the advantages and disadvantages of steam turbines, and list the applications of steam turbines. History of steam turbines. Anglo-Irish engineer Sir Charles Algernon Parsons invented the modern steam turbine in 1884. The first model of the steam turbine was connected to dynamo that generated 7.5 kilowatt of electricity. Let us see the classification of steam turbines. The turbines in which thermal energy of the steam is first converted into kinetic energy and then later converted into mechanical energy are called as steam turbines. According to steam action, steam turbines are mainly classified into two types: impulse turbine, reaction turbine. Let us focus on the working of an impulse turbine. Observe the diagram. Here, the impulse turbine is made up of casing, nozzle, and runner with blades. Working of a nozzle. Nozzle regulates the steam flow and guides the steam to flow at appropriate velocity. As the high pressurized steam comes out through the fixed nozzle, the pressure energy of steam is completely converted into the kinetic energy. Here, the velocity of the steam is very high. The steam flowing through the nozzle is called as jet. This high velocity jet is deflected on the blades mounted on the runner, where steam molecules apply the force on the surface of turbine blades. Due to this, turbine runner and shaft starts rotating. This shaft is also connected with the generator. Therefore, generator rotates and the electricity is produced. Let us study the working of this turbine in detail. The diagram shows the principle behind the working of impulse turbine. In this turbine, steam pressure remains constant while flowing through the moving blades. The velocity of the steam is very high while flowing through the nozzle and it decreases while flowing through the moving blades. Now, let us focus on the working of reaction turbine. In this turbine, the nozzles are attached with the guide wheel. These nozzles convert some part of the pressure energy into kinetic energy. The steam flowing through the nozzle is called as jet. This jet is passed through the moving blades with pressure and kinetic energy. The steam molecules exert the force on the blades and this causes the turbine runner and shaft to rotate. This shaft is also connected with the generator. Therefore, generator rotates and the electricity is produced. In reaction turbine, the steam expansion occurs continuously while passing through the blades. Thus, the steam pressure falls gradually. Whereas in impulse turbine, pressure of the steam is constant while flowing through the blades. In reaction turbine, the velocity of the steam decreases while flowing through the moving blades. Advantages of the steam turbines. It has immense load-bearing capacity. It is highly reliable. The cost of maintenance and lubrication of steam turbine is less. The steam turbine works with any type of boiler. However, steam turbines also have some disadvantages. There is some specific amount of time required to start and stop the turbine. It also needs expensive high pressure boilers to produce steam. Let us view the applications of steam turbines. The steam turbines are mainly used in the steam power plants. For example, thermal power plant, geothermal power plant, nuclear power plant, and solar power plant. In this session, we learned about the history of steam turbines, classification of steam turbines. After that, we studied the working of impulse and reaction turbines. Then we went through advantages and disadvantages of the steam turbines. And finally, we listed the applications of steam turbines.